In this video, I'd like to talk about the math question of the day for March 30th, 2023. And with this problem, we need to solve this radical equation. We have the square root of 5x plus 4, and we're subtracting the square root of x, and all of this is equal to 0. So we need to determine the x values such that this equation simplifies to 0. And with solving radical equations, you will need an understanding of Algebra 1 and likely Algebra 2. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And if you do have suggestions for future questions of the day, feel free to leave those as comments. And when solving radical equations, the general strategy is that you should solve the equation for one or both of the radical expressions. And then from there, you can square both sides of the equation to cancel out the square root. But in this case, if we add the square root of x to the other side, we can actually solve this for both radical expressions. And from here, like I mentioned, we will just square each side of the equation. Since, let's say we have the square root of 4 and we square it, the square root and the square cancel and we just get back 4. And you can see that if you take the square root first, the square root of 4 is 2, and when we square 2, 2 times 2 is equal to 4. So we get back 5x plus 4, and we just get back x here. Now we have a linear equation, which we can solve. We can move all the variables to one side of the equation, and I always recommend to move them to the side with more x's, and that way you can avoid negative numbers. So we subtract x on each side, we get 4x plus 4 is equal to x minus x, which is 0. And to get x by itself, let's subtract 4 on each side of this equation. We get 4x is equal to negative 4. And lastly, we can divide everything by 4 to cancel out the multiplication by 4, since 4 divided by 4 is just 1. So we get x is minus 4 over 4, or negative 1. Now, in general, when you do get a solution for an equation, you should plug it back in and see if it makes sense. But with radical equations, it's especially important to plug it back in, because with radical equations, often we end up with what are known as extraneous solutions. And it's a little bit complicated to understand where those come from, but the general idea is that, let's say this was negative, and when we solved it for the square root of x, we had minus this square root is equal to the square root of x. When we square both sides of the equation, this negative will cancel out because we're multiplying this by itself, and negative times negative is positive. So we will actually end up with the exact same linear equation. And that is an issue because we don't have this negative here. And the problem is we can't tell if this solution that we arrived at came from the equation we had or the equation where this was a negative. And of course, the negative could have been placed here, or I should say here, so this could have been positive. And again, that would have been a slightly different equation. So it's hard to say where this solution came from. Did it come from our equation or from this slightly modified equation? Since in both cases, we ended up with this linear equation, which led to this x value of negative 1. So the only way to know if we ended up with these extraneous solutions, these extra solutions you can think of, is to actually plug it back in and see if it works. And like I mentioned, though, this is something you should be doing anyways. Whenever you solve an equation, you should get in the habit of plugging in your value to see if it makes sense, because that's the only way you can be certain whether or not you're correct. Even if you've done this for decades, you will still make mistakes from time to time, but by checking your work, you can usually catch those mistakes. So we can plug in the value of x is negative 1. And now we're ignoring that negative and going back to the original equation. So when we check this, we plug it in, we get the square root of 5 multiplied by negative 1 plus 4. And we subtract the square root of x, which again is -1, and all of this should equal 0. Now, this is a little bit complicated. So when we evaluate this first part here, this square root, we get -5 plus 4, which is the square root of -1. And then we're subtracting the square root of -1. And we just need to remember that the imaginary unit is defined as the square root of -1. So we get I minus I, and something minus itself is equal to 0. So when solving this equation, it really depends when you are learning this. If the domain of the solutions must be a real number, then we would say there are no solutions to this, because we end up subtracting complex numbers here. However, if we extend the domain of solutions to complex numbers, then this value of x is equal to -1 actually does work here, since complex numbers are allowed. So it really just depends how your teacher might set up this problem. But if we are looking in a global sense at all possible number values, then we can say this does have a solution, and that solution is -1.